Hey guys, this is part 3 of the sample questions on the ACCUPLACER College Board test for the arithmetic section. Parts 1, 2, and 4 will be linked below, which contain the other questions. Number 11 reads, which of the following is equivalent to 8 over 25? Equivalent means which one is the same as. So we have 8 over 25. We know that the numerator is going to go in the box. The denominator is going to go out of the box. So we're going to set up our problem like this. We know that 25 cannot go into 8. So we have to add a decimal here and a 0. We're going to add a decimal here as well. And if you want, you can add a decimal there as a placeholder. So after we set this up, we can determine if 25 can go into our new number 80. Can it? Yes. So how many times does 25 go into 80? We can think of this as quarters. 25, 50, 75, $1. So our best answer would be 3, which we would get 75. We would have a remainder of 5. We would continue to go, add a 0 there, bring that down. Now 50, 25, 50, 2. 2 times 25, 50. You get a remainder of 0. So our answer that we got is 0.32, and that would be option B for number 11, 0.32. Number 12 reads, what is the remainder when 599 is divided by 9? So this could confuse some people. They may think to do this, or they may think this, or this. In each scenario, this one is the correct option and this one is the correct option. So you ask which one goes inside the box and which one goes outside of the box. In this scenario, this one would be the correct option. So this one, and this one are all correct. Everything else is wrong, and we'll give you the wrong answer. With that being said, we're going to clear this and start the problem. So 599 is divided by 9, meaning 599 goes inside the box, 9 goes on the outside of the box. Now, how many times can 9 go into 5? It can't. So we're going to extend the number to 59. How many times can 9 go into 59? That's 6, because 9 times 6 is 54. We subtract that. What is 59 minus 54? 5. We bring down this 9. We do it again. 6 times 9, 54. What is our remainder? 5. And the problem asks for the remainder. So this was a simple division problem. You had to know how to properly divide it by reading the words. And our option is B. Number 13 reads, a machine is currently set to a feed rate of 5.921 inches per minute, IPM. The machinist changes the settings to 6.088 IPM. By how much did the machinist increase the feed rate? So this part right here will tell us what we're doing. Again, it reads, by how much did the machinist increase the feed rate? I'm not sure if you realized yet, but this means we're going to subtract because we want to see the difference. We want to see the difference, the increase, because we have one number right here and we have another number right there. So initially it was this and it increased to this. So we want to see what was that change, by how much did it increase. So we have to find the difference. And difference means subtract. That's a key word. Difference means subtract. So we're going to subtract the problem like this. If we would have subtracted it like this, we would get the same answer just as a negative. But you cannot subtract the problem this way because you would get that negative. So moving over here, we're going to subtract this problem. 8 minus 1, 7. 8 minus 2, 6. Can we do 0 minus 9? No. So we have to borrow from the 6. It becomes a 5. Bring that 1 to the 0. So it's 10 minus 9, which is 1. 5 minus 5 is 0. And we bring down that decimal point. Remember, we have to line up the decimal points when we're adding or subtracting. So we line it up and we get 0.167 as our answer, and that is option A. Number 14 reads, which of the following correctly orders the values above from least to greatest? So we have least to greatest, and we're going to fill in the numbers right here into those boxes. So this number is in decimal form. This is in decimal form and has a percentage sign, and this is in fraction. So they're all different. So we have to make all of them in the same form so we can put them least to greatest. We're going to follow the decimal form. So 0.075 is good. Next, 0.75% we have to change. So this percentage sign is going to make this decimal place move over 2 places. 1, 2. So now the new decimal point is there, and we fill in this gap with the 0. So this is now 0.0075. Or you could just say 0.0075. Same thing, but I'm going to just add in this 0 as a placeholder. The last one is 3 over 4. You could do this long division like this and solve it that way, but I just think of it as a quarter. So if we have 3/4, we have 75 cents, right? So it's simply just 0.75. That's it. So we're comparing this number to this number to this number. So now everything is in the same form. Now we know which one we're going to be picking. So the least number would be the one which has the most zeros. So that is 0.75%. This guy right here. The second one would be the one that has medium, I guess, because it's in the middle. That would be 0.075, this guy. The greatest would be the one that has the least amount of zeros. 0.75, which is actually 3 over 4, and that's this guy. So the one that looks most similar to that would be A. That is exactly it. 0.75%, 0.075, and 3 over 4. So our option, our answer for 14 is A. Number 15 reads, what is the value of 2.84 times 3.9? This is a simple multiplication problem, but some people can get it wrong by the way they multiply. So this is the correct way to solve it, but if you set up the problem like this, you would have got it wrong. Basically, when you multiply, we do not need to line up the zeros. Sorry, we do not line up the decimals when you multiply. We have to line up the numbers. You only line up the decimals when you add or you subtract. The decimals do not need to be lined up when we're multiplying. So this is incorrect. This is the right way. So we're gonna do this problem right here. So we have 4 times 9, 36. 8 times 9, 72, plus 3, 75. 9 times 2 is 18, plus 7, 25. 3 times 4 is 12. 8 times 3 is 24, plus 1, 25. 2 times 3 is 6, plus 2, 8. We can add a 0 here if we'd like. 6 plus 0, 6. 5 plus 2, 7. 5 plus 5 is 10. 8, 9, 10, 11. So this is our answer right here. For the decimals, we have to add how many decimal places we have. So up here we have 1, 2. Here we have 1. So if we have 2 and 1, that's 3 decimal places we have to move. So we're going to start back here. We're going to go 1, 2, 3. So you know that our decimal goes right there. So our answer is 11.076, and that is option B.